The instructions for numbers 1 through 4 state if the given functions are inverses. To know whether or not two functions are inverses, we have to look at the composition of those functions. So if we had two functions, f of x and g of x, in order for those two functions to be inverses, f of g of x has to equal x, and g of f of x has to equal x. Both of those two things have to be true in order for these functions to be inverses of each other. So our two functions on number 1, g of x equals negative 4x, and f of x equals negative 6x minus 1. And we want to know if these two functions are inverses. So we're going to have to work out the composition of functions and see if we get x as our answer. If we do on both of these, then they are inverses. If we don't, if either one of these doesn't work out, then they're not inverses. You can just set them on the desk there. Thanks. Okay, so it doesn't really matter which one you do first. We'll just do f of g of x first. Oops. Okay, f of g of x. So really, you just have to compare f of g of x to f of x. So what's different about these two things is that f of x just has an x inside, where this has g of x inside. So what happens is anywhere there's an x in f of x, we're replacing that with g of x. So instead of negative 6x minus 1, now we have negative 6 g of x minus 1. So in our function f of x, this x matches this one. And now we're doing f of g of x, so this g of x has to match that. I'm making a lot of extra marks on my paper that you don't necessarily have to make if you don't want to, but it's just hard to explain without doing it. Now we're going to plug in what g of x is actually equal to. We know g of x is equal to negative 4x. So we're going to replace g of x right here with negative 4x. So we get negative 6 times negative 4x minus 1. Okay, so after you've done all those substitutions, now we're just going to see if we can simplify to get just x. So we can do negative 6 times negative 4x. We get positive 24x minus 1. And we can't really simplify this anymore. So we weren't able to simplify this down to just be x, which is what we needed. So we're allowed to say at this point that these two functions are not inverses. because we need f of g of x and g of f of x to both equal x. And just in doing f of g of x, we weren't able to get it. So we know already that they're not inverses. Okay, the other one that I'm going to work is actually number 3. So it's okay if y'all's papers are out of order, that's fine. But we're going to work number 3 together now. Okay, so our variable changed from an x to an n. That doesn't change the way that we work these. So we'll look at f of g of n first. My last class struggled with this one just in this part, especially plugging in the correct function in the correct spot just because the fractions are weird and it's just confusing if you don't focus. So we're using our function f because it's the outside function. So we're using this formula, -4 over n plus 2. But anywhere there's an n, we're plugging in g of n. So we get -4 over g of n instead of n plus 2. Now we're going to replace g of n with what g of n is actually equal to, which is this fraction. So it's going to be a fraction within a fraction. -4 over 4 over -n plus 2. And then plus 2 on the outside. So this n in f of n became g of n, and then we just replaced g of n with this fraction, which is what g of n is equal to. Okay, from here, we need to deal with this fraction. We're going to try to simplify this and see if we can just be left with n, just the variable. So in dealing with this fraction, this negative out in front either gets attached to the numerator or the denominator, but not both. And since the denominator is another fraction, I think it's going to be easier for us to just attach this negative to the numerator. So let's go ahead and rewrite that as -4 over -n plus 2, then plus 2. So the only thing that changed within these two steps is I just moved the negative from, instead of being in front of the fraction, now it's just attached to the numerator. Okay, let me show you a trick with dividing by a fraction. And you guys don't have to write this, but if we had something like 4 over 1/2. So this is 4 divided by 1/2. We can write this as 4 times 2 over 1. So the numerator stays the same. It doesn't change. division changes to multiplication, and then our fraction gets flipped. Instead of 1/2, now it's 2/1. So dividing by a fraction is the same as multiplying by the reciprocal of the fraction. So we're going to use that same concept with this fraction. So our numerator stays the same. It stays -4. We change division to multiplication. And then we flip our bottom fraction. So instead of 4/-n plus 2, now it's -n plus 2/4. And then we still have plus 2 on the outside. Okay, from here, let's go back to our more simple example. 4 times 2/1. When you're multiplying a whole number times a fraction, the whole number gets multiplied to the numerator. And it works that way because we could write 4 as 4/1. So technically here we have 4/1 times 2/1. And we would just multiply straight across. Multiply numerators, multiply denominators. So in our example, -4 gets multiplied by this numerator. So we have -4 times -n plus 2/4 plus 2. From this point, there's a couple different ways we could work this. The easiest way, in my opinion, is just to say that this 4/4 divides out to be 1. So really we can just cancel those 4s. And we end up with -1 times -n plus 2 plus 2. So now we can distribute this -1. -1 times -n is +n. -1 times 2 is -2 plus 2. -2 plus 2 is 0. So we're left with n, which is what we want. Okay, let me real quick just show you from this step. There's another way you could work this if you wanted to. I think it's going to end up being the same number of steps either way, but this way may come easier for you. So the way that we did it is we canceled these 4s out, and then we ended up distributing this -1. The other way to work it is to go ahead and distribute first to get, let's see, -4 times -n would be +4n minus 8/4 plus 2. Now we can divide both of these terms, 4n and -8, divide both of those by 4 because they're both divisible by 4. So 4n divided by 4 is n. -8 divided by 4 is -2. Then we're in the same spot where the -2 and the +2 cancel out and give us n. Either way, it both works out. So now we did f of g of n. Now we have to do g of f of n and see if that works. Okay, g of f of n. So now we're using g of n as our function, which is this 4 over negative n plus 2. But instead of this n right here, we're going to plug in f of n. Okay, so we have 4 over negative f of n plus 2. Now we're going to actually replace this f of n with what f of n is equal to. So 4 over negative, and now we're plugging in f of n, which is negative 4 over n plus 2. And we still have plus 2 after that. So all we did was replace this f of n with what f of n is equal to, which is negative 4 over n plus 2. Now, let's simplify this. So the first thing that needs to happen is get rid of these parentheses by distributing this negative. So that's 4 over, that just becomes a positive 4 over n and a negative 2 plus 2. Negative 2 plus 2 is 0. So we end up with 4 over n. So we're dividing by a fraction again, which means we can use the trick we talked about where the numerator stays the same. So the numerator is 4. Change division to multiplication and flip the fraction. So instead of 4 over n, now it's n over 4. This 4 gets multiplied in the numerator only. So we get 4n over 4. And the 4's cancel out to leave us with n. So f of g of n gave us n, and g of f of n gave us n, which is what has to happen in order to say that these two functions are inverses. Okay, so I'll go ahead and tell you of the two that you have left, numbers 2 and 4, one of those will work and one of those will not. So you should get one of your answers will be that they're not inverses and one of your answers will be that they are. And some of your fractions may get a little bit weird. Don't let that scare you off. So yeah, make sure you have, first of all, finished numbers 5 through 10 on that worksheet. And then all that you should have left after that is numbers 2 and 4. So see if you can get those done today and get that turned in.